Welcome to part 5 of the video series on buck converter BUC01. In this video we will make the buck converter work as a solar emulator. Or in other words, our buck converter will try to mimic the characteristics of a solar panel. For today's experiment, we have considered this current and voltage characteristics. The open circuit voltage is 23 volts. And short circuit current is 3.2 amperes. On any load condition, the buck converter maintains the output on this current voltage characteristics. We obtain this power curve on multiplication of the current and voltage values. The maximum power we can achieve using this characteristics is 45 watts. Now coming to the experimental setup. Here we have the buck converter which is connected to the Arduino board. Converter is powered from a regulated DC power supply. A rheostat load is connected to the output terminal. The output side current is measured using this ACS 712 current sensor. This is the connection diagram for Arduino in module. And this one is for load and current sensor. Let us quickly look into the Arduino program. Firstly, we include these three libraries. These are few variables used in the program. Here we list these 9 values for current and voltage so that the module can correctly interpret the IV characteristics shown earlier. In this section the parameters for PID control is mentioned. Proportional constant is 0.2 and integral constant is 5. Inside the setup function, digital pin 9 is set to generate PWM signal at 100 kHz. Inside the loop function, we first start by reading the output current. This line interprets the corresponding output voltage based on the output current value. In the next line, we read the actual output voltage of the module. Based on the difference between the actual and required output voltage, the PID control calculates the duty cycle value for the PWM. The PWM signal with desired duty cycle is then generated from digital pin 9. Here, all the data values are printed on the serial monitor. MOSFET temperatures are continuously monitored by these statements. So let us now upload the program. So we are back to the experimental setup. Let us power up the module. Input voltage is set to 28 volts. This is complete data displayed on the serial monitor. You can observe the output current value, the output voltage of the module, the upper and lower MOSFET temperatures, the duty cycle value of the PWM signal. Now we start decreasing the load resistance. You can see that the load current is increasing. And the output voltage is following the IV characteristics. We further increase the load current. And the IV profile is strictly being followed. In the next setup, we use these two 12 volts, 9 watt LED lamps in series and connect it to the output terminal of the module. You can observe the data on the serial monitor. Now if we power up the system, you can notice the change in the readings. And the red circle highlights the operating point on the IV characteristics. Thank you for watching. Place your order now. Link in description.